Guys, happy Monday. Welcome to Digital Day 6. I know it seems odd that we've been doing this for a whole week now, but you guys are doing a great job. We're moving on, talking about triangles. So the video that you should have watched prior to the notes, the Schmoot video, it was on the different types of triangles. So I just kind of want to review over those real quickly again. They talked about an acute triangle, which is all acute angles. Those are angles that are less than 90 degrees each. So an acute triangle has all three angles being less than 90 degrees. Then you've got a right triangle, which is exactly one right angle. So you have a 90-degree angle. You can't have more than one because then you wouldn't be able to create a triangle. Your obtuse triangle has exactly one obtuse angle, or an angle that is larger than 90 but less than 180. And that is an example right here. So like this is 115. That means the other two angles are some form of an acute angles. Then you've got the scalene. Scalene triangles are all different sides, all different angles. So this would be an example. Each of these sides is a different measurement. Each of these angles is a different measurement. And that makes it scalene. Isosceles triangle, you have two or more equal sides and equal angles. So for example, these two sides are equal to each other. These two angles are equal to each other. The third side, the third angle, those are not equal. Then you have an equilateral triangle, which is exactly as it sounds. Equilateral, all equal sides, all equal angles. So that means you will always have a triangle that is 60 degrees, 60 degrees, and 60 degrees for the three angles. So now we're going to move on to something that might be a little bit different, and that is the Triangle Sum Theorem. So the Triangle Sum Theorem states that if you add or take the sum of all three angles of any triangle, whether it's equilateral or isosceles or scalene or an acute or right, doesn't matter what kind of triangle you have. If you add all the sides together, it's always going to equal 180 degrees. So that means if I've got a triangle like the following, and the angle measurements, maybe I have x degrees for this angle, and then y degrees up here, and z degrees, then the Triangle Sum Theorem states that if I take x and I add y, and then I add z together, it's going to be equal to 180 degrees. Does not matter what kind of triangle it is. It will always equal 180. Okay, so let's go ahead and go on to another page, and we'll do a couple practice problems. I apologize for the sound in the background. My children are watching a movie. Again, if you need to pause at any time or rewind, you can always do so. Okay, let's do a first example. So my first example, I'm going to have the following triangle here. And we'll say that this is x, and this is 43, and we'll say that this is 119. It's not drawn to scale. I do apologize. I'm just trying to draw them quickly. So again, the triangular sum theorem states that I'm going to take all three of these angles and add them together. So I'm going to take x, and I'm going to add 119, and I'm going to add 43, and that's going to be set equal to 180. It's always going to be set equal to 180. All triangles are 180 degrees total. So now there's two ways you could go about this. You could combine the like terms together and then solve, or you could just individually subtract each of these away from your x and you'd be done. Personally, the best thing I think you can do is combine these together. It simplifies your expression here. So you now have x plus 162, because 119 plus 43 gives you 162, and that's equal to 180. So then the last thing that you would do is the inverse of addition. And the inverse of addition is to go ahead and subtract. So you would subtract 162 from both sides, and you would get that x is going to be equal to 18 degrees. All right, let's try another one. All right, let's do this. All right, so we have the following triangle here. Right off the bat, you should know that this symbol means that it is a right angle. So that means if I'm taking these together and I'm adding them, I'm going to have my x plus my right angle, which is 90 degrees, plus my other angle, my third angle, which is 35. And again, all three angles combined together should always equal 180 degrees. I want to go ahead and combine my like terms. So 90 plus the 35 is going to give me 125. So I've simplified this portion of the expression down to x plus 125 and set it equal to 180 for an equation. All right, and then you solve it. Inverse operation is to subtract 125 from both sides, and you'll get x is going to be equal to 55. All right, let's go for a third one. All right, let's say that I have the following setup. I tell you that this is 65, and that's all I tell you. That's 65, but I tell you that these sides right here are equal to each other. That's what these little dashes mean, that they're equal to each other. So if those are equal to each other, then that also means that these angles right here are equal to each other. So this angle, if I label it x, then that means the other angle would also have to be x. So I would have x plus 65, and that's going to be set equal to 180. I still need to combine like terms. Okay, before I was combining like terms with just numbers, just constants. Now I need to combine the like terms for these variables. And 1x plus 1x is going to give me 2x. So I have 2x plus 65 on the left side, and then on the right side I still have 180. All right, so now we just go ahead and continue to solve. Again, the first step is that inverse operation of subtraction. We're going to subtract the 65 from both sides. That's going to give us 2x is now equal to 100 and let's see here, 115. Then we would go ahead and divide both sides by 2. And that'll give us 57.5. So each of those angles will equal 57.5 degrees. All right. Let's try one more. And then I'll have you guys working on your IXL. So let's see here. I think maybe we will do, I'm looking through some old ones that I used to assign. Ooh, this looks like a good one. I think maybe we'll do two x, 5x, and 3x. 2x, 5x, and 3x. So again, the setup for this, we take all three angles and combine them together. 2x plus 3x plus 5x, and that's going to be equal to 180 degrees. Okay, so now we have to combine the like terms of just these variables. We don't have any constants to be able to combine together. It's just the variables that we're going to focus on. So 2x plus 3x is 5x, And then 5x plus another 5x is going to give us 10x. So we have 10x is equal to 180 degrees. Last step for here would just be to divide by 10, and you would get that x is going to be equal to 18. So we know x is equal to 18 degrees, but what if I wanted to know what do each of these angles equal? So if I know x, then I can take x and I can substitute it in. Instead of having 2 times x, I could have 2 times 18, and that would give me 36 degrees. I could have 3 times the 18, and that's going to give me 54 degrees. And then I could take 5 times the 18, and that would give me 90 degrees. And then if you were to check it, 36 plus 54 plus 90, look at that, it equals 180. All right, so that is it for this section of the notes. You can then go ahead and move on to your IXL. Don't forget, IXL always needs to be a SMART score of a 70.